Okay, so we're reviewing for the cumulative test, and this is all about quadratics. There was quadratics A tests, which was the easier quadratics test, and then there's quadratics B. And so one of the things that you have to know is if I threw a ball in the air and it followed this kind of a path, do you remember how to write the equation for that? I'll give you a hint. It starts with negative, and say it if you know it. 4.9. Good. And that means we're in meters because otherwise this wouldn't make sense. Negative 4.9 feet per second wouldn't, but yeah, all right. But that's in meters. And then I'm going to say t squared. And let's say I toss this ball at 4 meters per second and I started 1 meter off the ground. Can you write the rest of the equation? Tossing it at 4 meters per second. And by the way, if you're into physics, you'd have to know that technically we're only measuring the vertical here. We don't care how far away the ball gets from me. It's just how high the ball gets. And it's the vertical speed that we're doing. So when I said, did I say 4? Okay, plus 4t. And then I said it started at 1 meter plus 1. Raise your hand if you had that one right. Cool. Then I'm not asking you to do it because that'll take a long time. But do you know what formula you would do to get that spot, which is, and what is that spot? Would you please write those two things down? What is that? Hint, by the way, this is a ball, and so this is the height of the ball. And this has to do with the time. So what is that spot, and what is the formula you would use to get that answer? Edlin, do you know what that spot is? Time it takes for the ball to hit the ground. Good. And there's a formula for that. Let's go with Mr. Z. You were warm, but no. That's the beginning and the end of this big formula we're going to use. Negative b plus or minus the square root of b squared minus 4ac. All over 2a. Now, you, Mr. Z, were giving me the formula for that. What is that called, first of all? The vertex. And in this case, it's two numbers. Let's say it was as simple as 1, 4. What's the 1? This is the number of chickens in Venezuela? What is it? Well, apparently it's not that. What is it? It's the time. 1 what? Second. And at 1 second, there was 4 chickens in the coop. No. What do they think the 4 is? 4 meters of what? Height. The height was 4 meters. See, these each have a purpose. That's the time, and that's the height. All right. And that dot right there has a name, too. What's that number, first of all? 1. And it's the what? Initial or starting height, yes. Okay. And if you had to get this vertex, there's a formula for that. Don't say it. Please write it like a point. Did you have negative b over 2a? And then did you have f of that? Okay, cool. Next thing. You ever heard of I? What is it? I is equal to something. Don't say it, write it. And I squared is equal to something, and you better memorize it. We never did anything like that. Yes, we did. Because if I say this, you're going to run into an I and an I squared. The I part is just square root of -1. The I squared is much more important because it comes up a lot. What's I squared equal to? -1. So when I do this, I'd have 2I squared, which instantly turns into a -1. And so then this becomes -2. And then this 2I times the 7 is plus 14I. And you don't run around and change your i's to square roots of -1, but you have to know that that's what it is. So final answer, that's -2 plus 14I. Would you have gotten that one right? Okay. All right. Next thing. What if I had a quadratic where I knew the two x-intercepts, they were obvious, and they were at 4 and 6. And then we'll say that we knew the vertex also. And then you might think the vertex is at 5, 1. It's not. It's at 5, 2. That's important. You should be able to write the equation for this puppy. Because you got the vertex, so you can make vertex form. But be careful. A lot of people are going to make a mistake. I'll start with the first mistake. And so far, I've actually got 2 mistakes up there. Talk to the kid next to you about what the actual right answer is.
Oh wait, it's supposed to be vertex.
If the vertex would have been right there, then you would have been going over 1 and down 1, and that would not have had a stretch factor. But this did have a stretch factor. Did you catch it? Did you get it? It wasn't just that there was a negative in front. There is, but there also, it was a -2. Who caught that? Nice. And then it was also moved up 2, so I got to put a +2. Now my equation is complete.
Isn't it -5?
And that's right. I on purpose made that mistake, and then I forgot that I made the mistake. Okay, yes. That is a very common mistake. Right here. I said there was 2 mistakes. And the first mistake was leaving off that. The second mistake was that should be a -5. Now I better double check myself. Make sure that I've got this right now. So I got the -5, 2 in the right spots. I got a stretch factor. I got the negative for being upside down. Okay, good. Now it's actually right. Okay, so now what could you do with this? Hint. What's a common thing we ask that I haven't asked yet? What? Factored form, absolutely. Write this equation in factored form. There's several other questions I could ask, but that's the first one. Write the equation in factored form. Now, it is as simple as this -2 is still in your factored form. And then you have an x, and this is a positive 4, so you use -4, and x -6. Raise your hand if you had that one right. Cool. Then I've got vertex form, I got factored form. Now, could I ask you for standard form? Yeah, don't do it, but you just have to multiply this thing out. Okay, what else are typical questions about quadratics you got to answer? Hint. Axis of symmetry, what would it be? Don't say it, write it. What is your axis? Don't say it. What's your axis of symmetry? Say G. Do you know the axis of symmetry? X equals 5. He even said the x equals part. Nice. And then one last question that's not even visible on this graph would be the y-intercept. Would you please figure out the y-intercept? You can use any of the equations. You might be like, well, I have to multiply it all out now. No, you don't. You should have a reflexive reaction when I say I want the y-intercept, you go right away, oh, x equals 0. You've got to have that snap into your head. When I say y-intercept, you think x equals 0. Because then you can just put a 0 here and a 0 here, and it'll be easy. Or a 0 here. It'll come out the same, which is kind of cool. I got 48, but then I got to count that there's 3 negatives in it, so it's negative 48. Raise your hand if you had negative 48. Awesome. Do you get that as you look at the picture? There's no way it could be positive 48 for the y-intercept. Like, that wouldn't make any sense. It would have to turn around and go way up there. That wouldn't make any sense. And that has to be a negative because it was going to be down there. All right. Any questions? All right. Is that everything? No, that's a lot of things, though. All right. Can you factor? I hope you can factor. Let's try factoring an easy one. Why would you even factor? Well, if you're looking for the x-intercepts, you'd set y equal to 0. And then, if you can factor it, you should. What if you don't want to factor it? You could use the quadratic formula, but I asked you to factor, so factor. My way of factoring that I have come to over many years of teaching is you start with the x's, then you do the signs next. I think this is a way better way than trying to pick the numbers next. Because signs, you can use logic, and you can go, is there any negatives in the problem? Yeah, so this is negative. Now, can there be 2 negatives? No, because that wouldn't happen if you had 2 negatives. And so then it must be a negative and a positive. Then the last thing you do is think, what multiplies to this? Got to be a 1 and a 7. That's the only way the 7 would work, right? Just got to be a 1 and a 7. Then you just got to be strategic about where to put them. I want it to come out positive 6 at the end. So make the 7 the bigger one. And there you go. Raise your hand if you had that one right. Awesome. Now, what's factor form good for? This is not just a wasted question. This is something you have to know on the test. What's factor form good for? X-intercepts, good. What's this form good for? The y-intercept. It's sitting right there. Because the y-intercept is where x is 0. And that knocks out the first 2 terms. Okay. What's the other form good for? Well, the other form is called vertex form, so of course, duh, it's good for the vertex. So that's what each form is good for. All right. What if I said something had a x-intercepts of 2 and 5 and a vertical reflect and a stretch, a vertical stretch of 2. Can you write the equation for that? That stretch is also called the scale factor. The x-intercept of 2 means x minus 2, and x-intercept of 5 means x minus 5. And that vertical reflect means there's a negative out here. And then the vertical stretch of 2 means there's a 2 out here. Raise your hand if you had that one right. Okay, cool. So it's just writing an equation. All right. Can you factor this? Factoring's a little harder this time. This time you can't just, well, you can start with x and x, but then you got to be smart enough to know that that wouldn't work, right? So now what do? Can't be x and x. 3x and x. That's how you're going to make a 3x squared. Next, were you smart enough to know that there is a plus and a plus? Has to be. If it's all positives in the problem, it has to be all positives in the answer. Okay? And then the last part's really easy. It's got to be a 1 and a 1. Now, does this actually factor? No. That we were forced to do all the things I just said to make it be possibly right. But now you check it and you go, 3x and 1x makes 4x. That's supposed to be a 4x. Then this thing doesn't factor. Now, careful. Does that mean that there are no solutions? No. So if it doesn't factor, you could still get the solutions by using the what? Not b squared minus 4ac. That would only tell you how many solutions it has. How could you get the solutions? May have forgotten something. This is called the quadratic formula. I'm going to give you the follow-up. If you can factor it, you should. If you can't factor it, use the quadratic formula, because that works every time. It's true. Even if the answers are imaginary, you can get them from the quadratic formula. So let's do that. Everybody use the quadratic formula on this thing. X equals negative 2 plus or minus square root of b squared, which will be 4, minus 4ac, 4 times 3 times 1, all over 2a, which is 2 times 3. Now stop. Don't even finish it. Do you get I just did the whole quadratic formula? If the only question was, does this have real roots? You could answer it now. Will this have real roots? No. Say G why. The square root that you're going to do is going to be the square root of a negative. What's this part right here called? Hint, it starts with a D. Discriminant. What is the discriminant in this case? Yeah, but what is it? I know it's negative, but what is it? What's D? D is negative 8. That came from 4 minus 12. It's important that you know how to get the discriminant. So now that I know the discriminant's negative, do you get I know for sure that I don't have real roots? So if you had to pick which picture it was, could it be this? No. Could it be that? No. Could it be that? Yes, because that one doesn't touch the x-axis. This one has 2 roots. This one only has 1 root, and the kind that has only 1 root, what's that again? That's the vertex. If it's only got 1 root, it's got a 0 discriminant. So let's write out the discriminant cases. If the discriminant is less than 0, then one thing happens. If the discriminant is bigger than 0, then another thing happens. And the discriminant's equal to 0, then a third thing happens. Zero solutions that are real. I'll put real solutions. 0 real solutions. 2 real solutions. 1 real, and it's special. What is it? Vertex. So if I gave you this, would you be able to tell me how many roots it has? How many zeros? How many x-intercepts? Yeah, because you'd use the discriminant. All right, when would you ever use negative b over 2a? Well, do you know the rest of that formula? What's it equal to? If you don't know this, you should write this down. x equals negative b over 2a. Negative b over 2a doesn't mean anything by itself. It's the x. So do you get that's an axis of symmetry? X equals blah, that's an axis of symmetry, and it's the x of the vertex. Now, I just went over literally a month worth of math in that 1 hour. If it seemed like a lot, it's because it was. That was a month worth of math, because it was two 2-week tests. Now the big test is tomorrow. So I'm hoping that this video will, if you want to go home and rewatch it, you could. But there's more. I didn't cover absolutely everything you have to know, but I want to give you some time to work in class today. The only other thing I want to mention is I'm amazed at how many kids still don't know this. 3 plus and minus the square root of 27 all over 12. That's a problem where you could get simplest radical form, where, you're going to simplify it, simplest. It'll have a square root in it. That's why they call it radical form. And if you're like, well, I'll just use my calculator, well, then you're going to be getting a decimal, which is fine if they ask you for a decimal, but it's more likely that they were going to be giving you simplest radical form. So would you please simplify this down all the way, get the final answer to what you think it is. Start here. And then my favorite thing comes up. I'll pause for a second and give this one a try. Okay, if you didn't know that this was root 9 and root 3, which is 3 root 3, you would have probably been stumped. But I think most people knew that. So then you got 3 plus and minus 3 root 3 all over 12. And I think a lot of people are like, I'll just simplify the 3 and the 12. You can't. You can't, because this 3 is part of an add problem. You can't do that, so you have to do my favorite thing. Do you see that the top can be factored? So you've got to factor that. Raise your hand if you're already done. All right, then I'm going to factor that 3 out. And I have 1 plus and minus the square root of 3. If you don't know what I just did there, multiply this back out and you'll get what you had here. And then it's all over 12, but I'm going to factor the 12. Because if you can factor it, you should. 3 times 4. And then this 3 and this 3 cancel. And there's your answer. 1 plus and minus root 3 all over 4. That is called simplest radical form. How many of you would have had that one right? Sweet. All right, now you have a bunch of time. You have questions. I have answers. You guys work on practice problems. And there's 2 reviews with tons of practice problems in there. You should have plenty to do. Last thought, if you have any like you're going to be missing the test tomorrow, would you please come up to talk to me? Or if you have a missing test from one of the other 2 tests, like that'd be really rare, but there might be a kid who hasn't taken quadratics A or quadratics B. You should also come up and talk to me today.